Hello everybody, Bruce here with part 2 of Module 7. And in the prior video, I may have said Module 8, I'm not sure. But just know this is Chapter 8 in the book. And this is Module 7 in CTEC 121, Intro to Programming and Problem Solving. Alright? So just so you know, and it even says Module 8 slides there. So this is part 2. Part 1 is linked to in the notes here on the YouTube video. All right, let's carry on. So we're going to talk about computing with Booleans, and if and while, right? The if and while statements, constructs in Python both use Boolean expressions. You've already used them, but it's time to elaborate a little more about them. Boolean expressions evaluate to either true or false, right? Is x exactly equal to 5? Well, yes it is. Well, that's true, right? Is the student name not equal to Bruce? Why, yes, it is not equal to Bruce, right? So far we've used Boolean expressions to compare two values, right? While x is greater than or equal to 0, right? This would do the loop as long as x, right, is a number that's 0 or greater than 0, right? So greater than or equal to 0. Boolean operators. Sometimes our simple expressions do not seem expressive enough, right? So suppose you need to determine whether two graphics points, right, from the graphics library are in the same position. Their x coordinates are equal and their y coordinates are equal. Maybe you wanted to test for that. So how do you do it, right? Well, you could do something like that's on the screen right now. It says if point 1 dot get x, right, the get x point method is exactly equal to point 2's x value, and then you would have to nest in another if statement which said, well, if these two are, now let's check the y values to see if they're in the same point, right? So this is a series of nested ifs when we only want to check whether 2 points are in the same spot, right? So clearly this is an awkward way to evaluate multiple, tests, Boolean expressions, right? So let's check out 3 Boolean operators, and they are and, or, and not, right? So these are Boolean operators, and, or, and not, okay? The Boolean operators and, or are used to combine two Boolean expressions and produce a Boolean result. So we'll have some expression and some other expression. So we're going to test that this and this evaluate to true. If so, do something, right? Same thing here. If this expression evaluates to true or this expression evaluates to true, then do some stuff, right? So there is something called a truth table, and that's what this is right here. So the and, right, if we take two expressions is true exactly when both of the expressions are true. So check this out. So when we have, let's say we have two expressions or two things, P and Q. They're just random, P and Q. It could be A and B, okay? So when P is true and Q is true, then we say that P and Q are true, right? This and this evaluate to true. And when you have one of them equal to true, evaluates to true, and one evaluates to false, then when you and them together, P and Q, right, true and false, evaluates to false. When one condition is true and the other false, when you and them together, you get a false. And then when you have a false condition and a true condition, you get a false as well. See, notice how these two are the same. And when you have two falses, when you say false and false, that is also a false result, all right? So the only condition that evaluates to true with the and operator is when both are true. All right, let's carry on. In the truth table on the previous slide, P and Q represent smaller Boolean expressions. Since each expression has two possible values, there are four possible combinations of values, right? This table that's or, this one right here, all right? The last column gives the value of P and Q for each combination, and that's kind of what I just read to you. The OR Boolean operator, right, says the OR of two expressions is true when either expression is true. So let's take the first one when we have two expressions, right? True or true, right, is true or true evaluates to true, right? True or false also evaluates to true. And false or true, just like this one, it's the same thing as true. But the only time you get a false is when you have false or false evaluates to false. So either this one or this one evaluates to true, right? This expression or this expression. If they're both true and they have an or between them, they'll be true. True or false evaluates to true. And false or true evaluates to true, and false or false evaluates to false, okay? I know, new stuff, right? The only time or is false is when both expressions are false, okay? Both expressions are false. And I'll show you some examples of this shortly. Also note that or is true when both expressions are true. This isn't how we normally use or in language, right? In normal spoken language, right? So the not operator, all right? The not operator computes the opposite of a Boolean expression, the opposite. So not is what we call a urinary operator, meaning it operates on a single expression, okay? So I'll show you that too. So if we have an expression that evaluates to true and we say not that, then it's false. So we say not true, which means it's false. And if we have a false and we say not false, that means it's true, okay? So we can put these operators together to make arbitrarily complex Boolean expressions. The interpretation of expressions relies on the precedence rules for the operators, right? Which order and how they're grouped with parentheses, right? So consider A or not B and C. Whoa, mind explode. How should that be evaluated, right? A or not B and C, right? Pretend those are variables that have values associated with them, right? How should that expression be evaluated? Well, the order of precedence from high to low is not, it gets calculated first, then the AND operator, and then the OR operator, right? So this statement is equivalent to, right, the one in the first bullet, consider A or not B and C, is actually equivalent to not B, we put that in the parentheses here, and then ANDs go next, so this is and we AND these two together and we slap parentheses around them, and then OR, right, it's like a math thing here, right? It's just like math, how we would put parentheses around, right? So what I'm telling you is this is the order. Nots get calculated, then ANDs, then ORs, hence the addition of the parentheses around this the way that we did, okay? Since most people don't memorize the Boolean precedence rules, use parentheses to prevent confusion, okay? So you could keep it like that, right? But you're not going to understand it. So it's okay to put parentheses around the various portions of the expression to make it more readable and understandable. To test for the collocation of 2 points, we're back to the graphics library and 2 points, we could use an AND, right? We could say if the x value of point 1 is exactly equal to the x value of point 2 and the y value of point 2 is exactly equal to the y value of point 1, then we could do something else, we could do something else. So you see how we use this AND operator here to test this expression and then this expression, right? So the entire condition will only be true only when both the simpler conditions are true. This simple condition and this simple condition. All right. Whoops, where did I go here? All right, doink. So when you're writing, say, a racquetball simulation, this is used in the textbook, chapter 8, module 7, the game is over as soon as either player has scored 15 points, right? For those of you who've played racquetball, right? So how can you represent in a Boolean expression the score of player A is exactly equal to 15, or the score of player B is exactly equal to 15, right? So that would be the condition that would occur that you know somebody won, right? When someone scores either 15, right? One or the other scores 15, right? So when either of those conditions becomes true, the entire expression is true. If either condition is true, the expression is false. If either condition is true, the expression is false, okay? We want to construct a loop that continues as long as the game is not over, right? This is a racquetball game, all right? Again, covered in chapter 8 in the textbook, in the Zell book. You can do this by taking the negation of the game over condition as you loop through condition. So imagine writing a loop simulating a racquetball game where you say, while not score of player A is equal to 15 or score of B is equal to 15. So if score A is 5 or score B is 7, it's going to keep playing because neither player has scored 15 because we're putting not. So we're saying while not this player has 15 or this player has 15, keep playing the game, all right? That's really, it's used a lot where you negate this condition, this Boolean expression right here, all right? So let that sink in a little bit. So check this out. Some racquetball players also use what's called a shutout condition to end the game, where if one player has scored 7 and the other person hasn't scored yet, the game's over. So how would you write that? So look at this big expression here. While not score A 15 or B 15, or score A is 7 and score B is 0, or score B is 7 and score 0. But note how they have the ors here. So if you say this out loud and you think about it, yeah, that's kind of what it is, right? That will loop until any one of these conditions happens, right? All right. Let's look at volleyball scoring. To win a volleyball team needs to win by at least 2 points, right? In volleyball, a team wins at 15 points. So if the score is 15 to 14, play will continue just as it does if the score is 21 to 20. So check this out. Look at these expressions. If A is greater than or equal to 15 and A minus B is greater than or equal to 2, or B has a score greater than equal to 15 and the difference between B and A is greater than 2, so that would mean, right, either one of these would say, yep, they have 15 or more and they're winning by 2, right? So, and then this condition here says A greater than or equal to 15 or B is greater than or equal to 15 and the absolute value of A minus B is greater than or equal to 2. Whoa, just 2 different ways to write the same thing. That's what makes this stuff hard, right? Because you see it one way and you see it another way. Which way is it? It all depends. I'm sorry. The ability to formulate, manipulate, and reason with Boolean expressions is an important skill. That's why it's covered in this book. Boolean expressions obey certain algebraic laws called Boolean logic or Boolean algebra. Okay, so remember math, right? A times 0 is equal to 0. You all remember that, right? Anything times 0 is 0. So in Boolean algebra, A and false is exactly equal to false because 0 is the same thing as false, just so you know, okay? And A times 1, right? Anything times 1 is A. So here, A and true is always equal to A if you add those things together. A plus 0 equals A. Anytime you add 0 to anything, it's the same. So A or false is exactly equal to A as well, and has properties similar to multiplication in math, or has properties similar to addition in math. 0 and 1 correspond to false and true, respectively. So that's kind of important. When you have an expression and you're checking to see if something's false or true, you can also use the numbers 0 or 1. All right, so I think they show it here. Anything ORed with a true is always true. So if you have a variable A, or true is always going to equal true, just so you know. In fact, let me just flip over to VS Code here, and let me just create a program here, and I'll say A equals true, and true is capitalized in the language. And if I say print A, what was the expression? A or true? A or true, right? Let's see what this says. Let's see what this says. And it says it's true, right? Because that's what we learned right here, right? So if we do like this, right? If we do A equals true, I'm going to skip ahead. And we say A and true, what's that come out to be? That comes out to be true as well. What happens if we say false, right? A is false, false and false. Oops, false and true. What does it come out to be? It comes out to be false. And if I do A and false, so false and false is what? False as well, right? So again, new topic, and this kind of stuff is kind of interesting. So let me just show one more thing here since I'm here. So if I set A equal to 0, okay, and I say A, if I say, let's do this. Let's do this. If A is exactly equal to false, print, yes, I am false. Anyone care to guess what's going to come out here? So remember I said 0 is equal to false. So ready? Here we go. Yes, I am false because 0 equals false. And if I set this to 1 and I put an else here and I say print, nope, not false, right? Here we go. There you go. And if I change this to true, right? True is the same thing as 1. And I say true here, and I say true here. So if 1 is equal to 1, then print out, yes, I am true. So watch. There it is. All right, so I just wanted to show you that. I got a little off course here. And then you want to know that and or, what we call distribute. So check this out. On the left-hand side of both these expressions, we have A or B and C. That's the same thing as saying A or B and A or C. So what it's saying here is A or B, because it's like multiplication and distribution, or A and C. See? So these two expressions right here are equal. Same thing here. A and B or C is the same thing as A and B, or, because of this, A and C. Okay? I know this is hard stuff, but I just want to make you aware that this is very, very common in programming. What about double negatives? They cancel out. So if you say not A, right? So it says not A, which will negate A, and then the not of that, it puts it back. So like it says here, double negatives, double nots, cancel each other out. And then there's something called De Morgan's laws, which allow you to take this expression, not A or B, and that is the same thing as equal to not A and not B. So it kind of like distributes out here as well. And not A and B goes to not A or, right, not B, right? I know, it's kind of weird. Okay, kind of weird. So go back and watch this again. Boolean algebra, we can use these rules to simplify our Boolean expressions, right? So getting back to our, scorekeeping, while not score A is equal to 15 or score equals of B is equal to 15, continue playing, right? This is saying something like, while it is not this case that player A has 15 or player B has 15, keep going. And then if we apply De Morgan's law here, and we say while not score A is 15 and not score of player B is 15, continue playing. How about that? All right. I'm telling you, it takes practice and it'll begin to make sense. So this becomes, right, we can say this as well. While score A is not equal to 15 and score B is not equal to 15, continue playing. Now, isn't this easier to understand? While player A has not reached 15 and player B has not reached 15, continue playing, right? So we've done some of this before, okay? Not with while statements, but with if statements, all right? Sometimes it's easier to figure out when a loop should stop rather than when the loop should continue. In this case, write the loop termination condition and put a not in front of it. After a couple applications of De Morgan's law, you are ready to go with a simpler but equivalent expression, right? So that's what I have for Boolean algebra. There are some exercises in the book which I provide you the answers for. And I would go through them just to see how everything works. Just let me see if I can just do one more example here. So check this out. I'm going to say A is equal to true, right? And I'm going to say here, while A, right? Just like that, while true, do stuff, right? So what I'm going to do here is I'm going to say print hello, right? Just like that. And then I'm going to do, what am I going to do here? While A is true, actually, let's do this. While A equals 10, well, A is not equal to 15, right? Print hello, and increment A, A plus 1. So check this out. So while A is not equal to 15, do this stuff. A is 10, so that evaluates to true, and it's going to keep going, right? If I run this, right, it does it, how many times does it do it? Let me show you, right? 1, 2, 3, 4, 5, right? So you see how that works? The other thing you could do too is you could say, just do this, right? So get a number, we'll call it num equals int input, enter a number, enter 15 to quit, right? Enter 15 to quit, right? Just like that. So I'll just keep doing this, right? And I'll enter 22, right? It keeps doing it. That keeps going, right? Keeps going, keeps going. But as soon as I enter 15, oops, I blew that one. What did I do that for? This should be A. Sorry about that. I heard you telling me, but I couldn't hear you. So let me do it again, right? Just a whole bunch of numbers. And as soon as I enter 15, we are done. See, the loop terminated, right? And I said, well, A is not equal to 15, right? Right? You got that? Could I do this? Well, could I do this? Not A equal to 15. Do that. How about that? Whoops, I need another parenthesis here. Let's do this one, just to show you. Ready? So I'll enter 22, 33, 88, but now I'll enter 15. Loop is done. So I use that not there to negate this condition. While A equals 15, while not, so it's negating that, all right? All right, thanks for watching. This is part 2. And make sure you watch part 1 before you watch part 2 here, and have a good Module 7.